dealing with exponential transformations, I want to just kind of spend some time exploring those and seeing kind of what that looks like before we do our notes. So we're going to start just kind of by stepping through each of these instructions. So we're on Desmos.com, and when I went there, I just clicked on Graphing Calculator, that's one of the first tabs that you see when you pull it up, and it brings up this screen, and we are going to walk through this exploration together. So first off, ask us to graph these two functions. Oops, excuse me. So I'm going to do y is equal to 2 raised to the power of x. If you are needing that exponent, if you click the little keyboard down here at the bottom of your screen, there's an exponent here. And if you'll use this one, only is square, but if you use the a raised to the b, it'll give you option of typing in whatever you need to type in. So I'm going to delete that, and I'm going to go ahead and go on to the next one, where I have y is equal to 10 raised to the power of x. So you may ask, why am I putting in y instead of f of x? Just remember that it's the same thing. So I'm just making it a little easier on myself by using y. Alright, so what we notice here is that the red line on the graph is going to be our first one, has the little red line here, and the blue one is the second equation. So we have the question that y is equal to 10 raised to the power of x rises, and in this case it rises faster or steeper than the graph of 2 raised to the power of x. So I'm going to call that steeper. If you want to call it faster, however that works for you. And they both have this y-intercept at the point 0, 1, so where they cross the y-axis. Alright, so the second step asks us to take that same first equation and change this second one from 10 to 0.5. So I'm going to go ahead and do that, and you'll see what happens here is that the graph of f of x is equal to 2 raised to the power of x shows exponential growth. You'll notice that that is getting larger, or moving in a growing direction, whereas the other shows exponential decay. And we've already talked about those two terms and what they mean. We've also talked about how this b value, when it's greater than 1, is growth. When it's less than 1, between 0 and 1, then it's decay. And now what this happens is this is a reflection across the y-axis, where it's been flipped sideways. And they both of these have, again, the same y-intercept of 0, 1. Okay. Alright, so moving on with our exploration. Again, we're going to use 2 raised to the power of x, but we're going to compare it this time to negative 2 raised to the power of x. And what we'll notice is that these two have now flipped directions, and so you'll see that we now have a reflection across the x-axis, where they have flipped across that x-axis and they're upside down. And that's that reflection that we've discussed before, things that we've seen in the past, where a, when that value is a negative number, it tends to flip over the x-axis. The y-intercept, we notice, of the first one is still at 0, 1, but the y-intercept of this bottom equation is now at 0, negative 1. So that has flipped as well. Alright, so we're going to look at another example here. This time we have 2 raised to the power of x again, and then the next one we have is 2 raised to the power of x plus 5. Okay, so you'll notice they're going in the same direction, they look exactly the same, but in the first one, this red one, we have a y-intercept at y is equal to 1, and a horizontal asymptote. That horizontal asymptote here is at y is equal to 0. It gets closer and closer to 0, but never actually crosses the line 0. Then we have this other one that has a y-intercept at 6 and a horizontal asymptote at y equals 5, where it gets closer and closer to this line at 5, but never actually crosses it. So this means that there is, what we've noticed is that this whole red line has been shifted up. So this is a vertical shift of 5 units up is what has taken place here. Okay, so let's continue on looking at the next little piece of this, where we're going to graph the next two, and this time we're going to change this plus 5 to a minus 5. And what we see is that the red one still hasn't changed. it still has a y-intercept at y equals 1, and it still has a horizontal asymptote at y equals 0. What's different here is that this minus 5 is has a y-intercept at -4 and a horizontal asymptote at y equals -5 in this case. This is the line here that's not going to cross. So in this case, there's still a vertical shift, but it's been going down now instead of up. Okay. All right, so in the next question, we're asked to predict how is the graph of f of x equals 2 raised to the power of x minus 10 different from this first graph. So without typing anything in, we're just going to kind of look at this, whereas up here we had raised to the power of 2 raised to the power of x minus 5, and on here we have minus 10. And we notice that the change, it had a different y-intercept, where we took the y-intercept of 1 and we subtracted 5 from it and to get the -4. So I would assume that we would do the same thing here, where we have a 1 for this red line that we have been working with, and we're going to subtract 10 from that. So I would say that most likely our y-intercept is going to be at -9, and the horizontal asymptote up here was at -5. It was the same number as this right here. And up here, the horizontal asymptote, there wasn't a number added out here, so it was at 0. So I'm going to make this assumption that it's going to be the same situation on here, where the horizontal asymptote in this case is going to be at -10. Meaning that there's going to be, again, another vertical shift, and just like this one was a -5, this is a -10, I'm going to assume it's going down. Okay, all assumptions that I'm making based on what I'm seeing, but that's kind of the point of this exploration. So let's plug it in and make sure that that's actually true. So I'm going to graph that, and what I notice is that it does have a y-intercept at -9. The horizontal asymptote does seem to be at -10, and it has been shifted 10 units down from this original line up here. So I think we were in the right direction as we were answering that question. Alright, so looking at the next one. So now, this time, instead of making a change out to the side, we're actually going to put some parentheses up here, and we're going to change the exponent. So we're going to make this an x plus 5, keeping again that red line still the same. So you'll notice that this still has the point 0, 1, not the same y-intercept up here. We're not going to look at that though, but it asks us, it contains the point what comma x. So we want to see where y is 1, and in this case, this blue line, let's see, 1, it is -5 comma 1. And so this means that what's happened here is that this whole red line has shifted to the left. So that is a horizontal shift to the left. Okay, so looking now at the next one, where what we've done is taken this and subtracted 5 instead of adding 5. Again, this first line, oops, I'm sorry, I didn't do that correctly. -5, there we go. This first line, the red line, has still has its y-intercept of 0, 1. But then if I look over here, I'm looking for a y value of 1, and the x value that matches with that, or that corresponds in that ordered pair, is a 5, 1. So again, the whole graph has shifted to the right 5 units. And so that's, again, a horizontal shift. Okay, so what you're hopefully starting to notice is that when we have these numbers that are outside of the exponent, that's going to be our vertical movement up and down, and we've seen this before when we dealt with linear translations, and we'll see it again when we deal with quadratic translations. This number inside dealing with the exponent is a horizontal shift. Okay, and so we'll get this all kind of summed up here in just a few minutes, but we've got a couple more things I want to look at. So number 9, we're going to predict this time what happens if I change this from a 5 to an 8. Well, up here, the -5 was still a horizontal shift, and I think that's going to be the case again. And I think it's going to be a shift of 8 units, just like this one up here was 5, because that was the number that we're dealing with. And because this was a minus 5 and this is a minus 8, I'm going to assume it's going in the same direction, so it's going to be to the right. And you'll see that that's exactly what happens when we change that. Here we have the point 0, 1, and here we have the point, 8, 1. So we've moved 8 places to the right. It's a horizontal shift there. Alright, just a couple more things I want to go through with you. Looking at number 10 here, we want to graph the following functions in Desmos again. These are a little bit different. So here we're dealing with 1 times 2 raised to the power of x, and again, if you need the multiplication symbol, it's down here, or you can use the one that's on your keyboard. That would be Shift 8, would also get you there as well. And then here, I'm going to take out this minus 8 in my exponent. I'm going to leave the x, and I'm going to do 4 multiplied by that, 2 raised to the power of x. So what I deal with is this first line, 1 times 2 raised to the power of x. It's the exact same line we've been dealing with. All I did was go ahead and write out what that a value was. Remember that the equation for an exponential is y is equal to a times b raised to the power of x. And when there's not an a there, we assume it to be 1. So here I'm just writing out that 1. That's always assumed to be there. And then here we've changed that to a 4. So with this first line, we still have a y-intercept at y equals 1. That still hasn't changed. But now we have a y-intercept at 0, 4 for this other line. So in theory, we could also say that the graph of 11 times 2 raised to the power of x would have a y-intercept at y equals 11. And we can check that just to see if that's the case. I can change out this 4 for an 11. And yep, I have a y-intercept at 0, 11. So it works. Now, I want to graph these others. So this time I'm going to take out this original. We're going to change it to 3 times 2 raised to the power of x. And here I'm going to do the 3 times 2 times the power of x again, but I'm also going to add a plus 2 to the end. So what we notice here with the first line, 3 times 2 raised to the power of x, it now has a y-intercept of 0, 3, and a horizontal asymptote still at y equals 0. Okay, but then we make a change. Okay, so we had the 3 and the 0. Now we're going to add 2 out here, and what we've seen before when we added 2 was that it was a vertical shift. So here, in theory, it should go up 2 places, and it did. So that means that I'm going to have a y equals of 5 here for my y-intercept, this point right here. It's at 0, 5. And then the horizontal asymptote this time, instead of at 0, is going to be at 2, because we've moved the whole thing up 2 units. So we took this and we added 2 to it. So we are shifting that. You'll notice that my y-intercept here was no longer 1, it was now 3, because we've done some changes to that a value as well. So that's something that has slipped up, or has changed a little bit as well. Alright, so one more that we want to look at here. We're going to ask to predict what will happen if we have 4 times 2 raised to the power of x and 4 times 2 raised to the power of x plus 3. So very similar to this last example that we did. We're just changing out the a in both of these and then this number out here on the second equation. So I'm going to predict that this has a y-intercept of 4, and I'm going to predict that because up here this 3 carried down to this original equation, or to this y-intercept. So I'm going to say that this 4 in this one is also going to carry down with a horizontal asymptote still at 0, because nothing has changed as far as that goes. And it's going to be very similar, because the only difference between this problem and this problem is it went from a 3 to a 4. So I think that the 3 and the 0 probably going to be the same here. It'll be a 4 and a 0. Now here, everything shifted 3 up. That plus 3 is what we've seen to be a vertical shift up. So that means that the y-intercept is going to go up 3 positions. So this 4 plus 3 is going to become a 7. And the horizontal asymptote that was a 0 is going to go up to a 3. Okay, so that's my prediction. Now we want to check that. So here we have 4, and then here we have the 4 as well, and then we added 3 to it. And so in the first one, you'll notice this red one, we have a y-intercept at 4 and a horizontal asymptote at 0. So that's exactly what we predicted. and then we have this y-intercept at 0, 7, and the horizontal asymptote at 3, y equals 3. So you see that what we predicted actually came true. All right, so we've taken this these exploration, and so now we're going to sum it all up in just a quick little set of notes just to help us really fully understand all that we've just seen. That was a lot of information and a lot of different changes and different numbers and different positions. So we're going to sum it all up into one easy way to look at it here in just a minute.